Alright, this is part 2 of Learning Module 1, where we wanted to break up the first learning module into 3 different videos. Let me just back up here. Learning Module 1, Part 1, talked about what is software engineering. And so this video is going to talk about what is software development lifecycle. Now, I mentioned there's going to be 5 to 10 minute videos. The last one, I thought I could do it in 5 to 10 minutes. It actually took about 15 minutes, so apologize for that. So let's jump right into what is the software development lifecycle. Alright, so as I kind of alluded to in part 1, when we develop software, software goes through a process. It goes from a beginning to an end. Okay, so our software engineering process is just a collection of activities, and they are taken in a certain order. Okay, and so for software, we call this the software development lifecycle. Okay, so we have some concept of a beginning. There's an idea that somebody has, or there's a problem that we're trying to solve, or there's an opportunity to take advantage of a certain market. Whatever it might be, there's an idea and there's a need for software to potentially be built. So we have a start. Then we go into so we have the need. Then we go into our problem analysis, where we understand what needs to be solved. And so back here on the need, it might be just some high level concept. I want a new app to track parking spaces on campus. And so at this point, it's just an idea. During problem analysis, this is where we're trying to understand in detail what that actual problem is. Why do you want an app to track parking spaces at campus? What's your goal? What's the objective of this app? So we thoroughly understand the problem. We identify what success would look like. Okay, so you want to solve the parking problem on campus. You want to make it students more aware or more informed of where there are empty parking spots. And so maybe there's an app that needs to be built. And so what would success look like? What does success look like if students are able to find parking spaces within 1 minute or something like that? I don't know. You identify what does success look like during problem analysis. And then you end problem analysis with feasibility study, and where you're looking at, we said an app needs to be built. Well, we're kind of jumping the gun. We need to do a feasibility study to understand, is an app really going to solve the problem? Is it going to be the most cost-effective way to solve the problem? Are we going to be able to actually build it in time and all that good stuff? So we're doing a feasibility study to understand, is it feasible? Is this the right path to be on to solve this problem? If all of that looks good, we're going to leave the problem analysis and we're going to go into the design phase, where we're looking at what are the multiple solutions that we could take to solve this problem. It's always a good idea to come up with a couple, 2 to 3 options as far as design solutions, because if you stick with just building one design solution, you're coming up with one solution, then you typically get married to that idea. And so it's hard to get away from that idea if there are problems later on. And so during this design phase, this design step, we're trying to look at how we can solve this problem that we just understood in the previous step. And then after the design solution, we need to come up with, well, which one are we going to go with? Because then we flow into the implementation phase, and that's where we actually build the product. Write all the software, you build whatever hardware you need, and all that good stuff. We test it to make sure it's actually going to work. We test it to make sure that when we define success back here in the problem analysis phase, during testing we determine, were we successful? Did we meet that success criteria? And then of course we operate it and maintain it. So during this O&M phase, operations and maintenance, we deploy the solution out into the wild, into operations, and then we maintain its operational status. That might be like have a help desk and things like that. Okay. So the intent of this slide here was to go over that we have this concept of a software development lifecycle from beginning to end. The process starts, we have some kind of idea or a need, we understand the problem, we design multiple solutions, we implement one of those solutions, and then we deploy it. This is the development lifecycle that we're talking about in this first step. Okay. Typically what these phases are called, and I'm a little bit hesitant, but I guess it's fine. There's a little bit of error in what I'm saying, But typically what these phases are called is the planning phase, the analysis phase, design phase, these phases right here. Now, does every organization follow exactly these steps? No, not necessarily. And that's what we'll get into in part 3 of the video series of Learning Module 1, and that is there are different methodologies in implementing these phases, okay? But a structured approach in building a software system will follow, will have some type of steps to it, and a generic set of steps that you can take are these right here: the planning, analysis, design. Okay, and we're going to talk about these a little bit more involved in depth. But let me transition a second. So these are the steps that we go through. These aren't all the activities that are performed on a project, though. Additional activities that are performed in parallel of these phases are these activities over here, to where you have to make sure communications. We have to be communicating with our stakeholders, our customers, as well as making sure that internally we're communicating well amongst all the team members. Another activity is project tracking and control. We're going to be putting time frames or time boxes around these phases. We're going to be making sure that when we enter a phase and exit a phase, we've achieved what we've wanted to achieve. We want to make sure we're hitting schedule. We want to make sure we're hitting cost margins. That's our project tracking and control. Okay, so we'll talk about each one of these a little bit more in depth here in a couple slides. So relative to these phases, the software engineering lifecycle, what goes on during these phases? Well, I'm getting a little bit more refined from the cartoon that we looked at here on slide 9, and now we're talking about the formal names for these phases. The planning phase. This is where we're defining what the system is to be developed, identifying the scope of the project. We're coming up with project plans, resource needs. Are there any agreements that need signed? And so we're basically standing the project up. Then we'll fall into the next phase, which was analysis, where we understand the problem in greater detail by actually establishing what are the requirements for the system and the software that needs to be built. It is during this phase right here, the analysis phase, that we are identifying what. Let me say that again. We're identifying what needs to be built. We're not identifying how something should be built during this phase. During the analysis phase, all that we're capturing is what needs to be built. Then we're moving into the design phase, which is actually going to talk about, that's where we come up with the hows. How are we actually going to build this? It's critical that we stay design agnostic out of the analysis phase, because we will miss requirements. We will miss the needs of the end user, the stakeholders, the customers, if we only think about how we're going to build something. And so it's very critical that we get this step right, this phase right, that we understand exactly those requirements that the end system needs. That's it's going to make or break us. And you're going to see once we talk about these different development methodologies, you're going to see it is the analysis phase where we establish the requirements. Those requirements actually define what is success and what is failure. So if we get towards the very end of the project during operations and maintenance, if we have left out a requirement that should have been identified in the analysis, then you can consider that failure. So this analysis phase right here is the most important phase of this entire development life cycle. If you mess things up here, your project is on a wrong path. So we leave the analysis phase, we understand the requirements, what needs to be built. We go into the design phase, and this is where we come up with the hows. How are we actually going to build a system that satisfies these requirements? Then we go into the implementation phase, which actually we fabricate, write code, build databases, build the data structures, whatever it might be. We actually build the system that was designed in the previous phase. Then we enter into the testing phase. During the testing phase, this is where we actually exercise the software to try to make sure that it meets the requirements established in the analysis phase. Very critical. So during the testing phase, we're trying to weed out all the problems we can possibly find in the software. And we're making sure that all of the requirements from the analysis phase have been implemented. And then during the operations and maintenance, the O&M phase, that's where we're deploying the system, we're developing training, getting people familiar with it, able to operate it, having a help desk. We're modifying the software to fix where there's problems, because we do have problems that escape testing. And once we get it, deploy the software, there's going to be problems that surface, and so we got to fix them. And so that's where we develop the environment so that we can change the software and then redeploy it. Okay. So here's that generic look at the software development life cycle. Here's the phases: the planning, analysis, design, implementation, testing, and then O&M. Okay. So quick overview, maybe 3 minutes worth. Then we transition into, these are the phases. Here are those parallel activities. These go on no matter what phase you're on, that you're in the development life cycle. So you are constantly communicating. You're making sure that what have you put in place so that communication can occur on your project seamlessly. You're making sure it's working. You're making sure you're communicating with your stakeholder, your customers. You're making sure that the team is communicating. So it's during, let's say we're during the requirements phase, or during the analysis phase, when we are generating requirements, we have to make sure, and let's say we're building a system for its control software for a vehicle, we have to make sure that we have our mechanical folks, our electrical folks, we have to make sure that we have all the right people. So we have to make sure that all the different disciplined experts are at the table communicating so that the right requirements can be extracted, documented, and established for our project. So we have to make sure not only are we communicating with our customer and our stakeholders, our end users, we also have to make sure communication is going on seamlessly internally to the project as well. Another activity that goes on, no matter what phase we're on, you got to track the project, got to control it. You have to take necessary actions to make sure you stay on cost, within budget margins, within a certain risk profile. And so this is taking charge of the project, basically. Risk management is conducted at all times. Risk management is an activity to where we formally manage the concerns that we have on the project. What concerns us is that we're not spending enough time on the requirements of the project. That's concerning. So we might write a formal risk that says, look, given that we're only spending maybe 2 hours a week in generating the requirements, there's a concern that we're not going to be able to capture all of the requirements needed. So based on that risk, we could evaluate our schedule and determine, hey, can we spend any more time? Anyways, how you mitigate the risk we'll talk about that when we get into risk management. But risk management is an activity that you formally devote time to make sure you identify, track, and mitigate the concerns that you have on the project. And then quality assurance is conducted during every phase as well. It's making sure that you are performing the right things, the right activities that will make sure that our product, from beginning to end, will be of the utmost highest quality. We don't want to have the quality escapes, is what we call them in the well, it doesn't matter. What we don't want is problems to escape our phases, and our customers realize them whenever they're using the end software product. So quality assurance is put in place, and we do certain activities, like during the analysis phase, for example, when we say that, hey, we think we've captured all the right requirements. Well, the quality assurance folks are going to analyze those requirements and basically have a separate set of eyes determine how well have you captured all the requirements. And so that's what quality assurance. In quality assurance, we'll be testing the software when we come out of the implementation. Remember, we had that phase testing. This is where quality assurance is exercising the software. They're looking for software problems. Okay. Another parallel activity that we do is technical reviews. It's where we actually formally hold our colleagues. But sometimes it's done. It's typically done at the end of each phase, in the beginning of each phase. So once we think we're done with analysis and we're going into the design phase, we'll have a technical review to where our colleagues will present amongst ourselves as well as the external stakeholders, and they will present, like for example, if we're leaving the analysis phase and going into the design phase, we'll present what the requirements are, and we'll get feedback from the external stakeholders as well. So it's a way to basically measure where we think we are on the project. It's a way to also enforce some quality and rigor into the engineering artifacts, like for example the requirements document. If you don't have a technical review, sometimes your requirements can live on a piece of notebook paper and get lost or whatever. When you hold a technical review, then typically folks will build a formal presentation so that they can be presented. So you're adding some rigor to your development effort when you throw in you're going to be conducting technical reviews. Another parallel activity measurement. This is where a measurement program for a software project is where we define the what we're going to collect, what indicators are we going to use that will allow us to gain insight into progress. How well are we hitting schedule? How well are we hitting our cost margins? How well is the technical quality of the software? Or how good is its quality of the software? And then what is our risk profile? We need to have a way to have indicators that tell us how these things are going during the life of our project. And that's measurement. That's having a measurement program. And it's an activity that's done no matter what phase you are in the project. And then there are CM activity or configuration management. Our software and all of the engineering artifacts are going to go through many versions. I've been beating up this analysis phase a lot, and so when we leave the analysis phase and enter the design phase, we're going to have a set of requirements. Those requirements are going to be documented somewhere. That's going to be version 1 of the software. Our configuration management process is going to dictate how do we change the requirements in that requirements document. So you go from version 1 to version 2, what's the process look like? If somebody has a comment against the requirement, what's the process? Can they just go in and edit the document, or do they have to actually submit a recommendation to change a requirement? So whatever that might look like, that's part of your configuration management parallel activity that goes on. Those activities go on whether you're in the analysis, design, implementation, testing, doesn't matter what phase you're in. All of these activities have to be performed at some level of rigor. Okay? And here's where I'm trying to get at. If I'm building an application, let's say Marcus Fisher, am building an application for the phone, an Android app, and it's so that my kids can play a game. All right? And it's a tic-tac-toe game. Well, these phases, first of all, let's look at this. These phases of the software that I'm going to go through in establishing that Android app, I'm not going to be that rigor in establishing a project plan, for example. I'm not going to develop a project plan. I'm not going to estimate the resources because I'm the only one working it. Why would I do all that work for this planning phase? Okay, so I'm not going to put a whole lot of effort into that. I'm probably going to spend a day, maybe 2 days, maybe writing down some things or drawing some pictures on what the requirements of that app might look like. Show them to my kids and say, what do you think if you played a game like this? How would this look? So I'll get some feedback from them. Then I'll probably sit down on paper, scratch paper, and just start designing things out. I'm going to write things in, if it's an Android app, I'm going to write things in Java more than likely. Or am I going to use a app generator? There's some applications out there that allow you to automatically generate an app. So I'm going to come up with that design. Okay, then I'm going to actually implement it. I'm going to exercise it a little bit, test it, and see if it works, and then I'm going to load it to the Play Store and let my kids download it and they can try it out. This whole life cycle that I went through was very informal. I didn't spend a whole lot of time during the design phase, let's say. Okay, I spent more time in the implementation and testing, let's say. The point is, that system that I was building is different than maybe the software for a bank or the software that controls the braking system for an automobile. Those types of systems, are a lot more critical, require a lot more rigor, more discipline. Remember our three characteristics for engineering, for software engineering. It requires more discipline, and so you're going to spend more time in these phases than I will building that Android application. Okay, hopefully that's making sense. Depends on the organization. It depends on the type of system you're building. So that's the engineering life cycle, the activities that are going on during that life cycle. And now let's bring it back to you all. Lifecycle management, managing this whole beast. So managing this development life cycle right here, managing these parallel activities, making sure they're done and being done well. So you're just not making sure that these phases are going on, by the way. Your job is to make sure they're going on, but they're being done well. Okay? And so what your job is to ensure that the software, number one, will satisfy the requirements as well as the technical quality expectations. What is the quality of the software? What is the expected quality of the software? For me, building, sometimes we label that as what's the reliability of the end product. If I'm building that Android app that the kids are going to play, is it okay if there's an error in that software, in that app? Sure, the kids might be disappointed, but it's okay if there's an error in it. So the reliability doesn't have to be that high, okay? But if it's the braking software for an automobile that, electronically control the braking of a vehicle, well, now the reliability has to be a lot more higher. A lot of folks aren't going to tolerate if the brakes don't work, for example. And so you have to, back in the analysis and understanding the problem phase, you're establishing what success looks like. Well, what you have to make sure is that as the manager of the software product, you have to make sure that the software is not only meeting the requirements, but it's also meeting the quality expectations as well. How reliable is this software? How safe is this software? How secure is this software? Okay. So you can't just pick this item. You can't say, well, the software met all the requirements. However, our budget estimate was I needed $10,000 and it costed us $30,000. So it costed you 3 times. But we met requirements. That's unacceptable. So your job is to basically balance. These are all the balls you got to juggle. You got to satisfy the software's got to satisfy the requirements. You got to make sure you're within costs. You got to make sure it's delivered when needed, and it's all within some tolerable risk profile. You're going to have to accept some risk. You're not going to be able to mitigate every concern that you have. But is the risk acceptable? And so that's where you've got to manage it down towards is the risk acceptable? So really when you're thinking about it, when you're looking at an iceberg floating in the ocean, what we're trying to manage or what we're trying to avoid is the iceberg that's under the water, what we can't see. Okay? And so we use as kind of like the 3 legs of a chair. You can't have a chair that stands up without these 3 legs. We got to manage the technical performance. We got to manage the schedule. We have to manage the cost. You can't focus on just one of them or this chair is going to fall over. All 3 legs of the chair has to be stable, in place, and you've got to focus and manage all of them. Okay? So you can't focus on just one. Here's a picture I cut and pasted from the internet. What I wanted to start introducing to you to make sure that it's on your mind. We don't have to be well versed in it yet, but we have to make sure that you're thinking about it is as we go through our phases, so the planning phase, the analysis phase, the design phase, not only are we going through this life cycle, but there are engineering products that are coming out of this life cycle that makes up the software. Remember, go back to the first video. Software product is more than just code. So for example, when we come out of the analysis phase, there's a software requirement specification. That is a software product. That is when somebody says, I need the software. Well, software is made up of many things, just not the code. Well, it's made up of the software requirements. It's made up of the software design. It's made up the actual code and the documentation on the code. It's made up of the actual tests that are executed. So I wanted to show this picture that correlates the engineering artifacts that get generated during these phases. Okay, so this is the entire picture that you're going to be responsible for managing and making sure that, again, when we get to testing, we want to make sure that the software satisfies the requirements that were established back here within the technical quality expectations that we've established back here. We want to make sure that we've hit the schedule, that we've built this software and got to the testing phase in the right amount of time. We want to make sure that we've hit budget, that we haven't spent too much money getting to the testing phase, and we've done it all within a acceptable risk profile. So here's the picture. This is what you're dealing with in this class, and if you do work on software projects, this is the picture that you're looking at. And of course, like I said earlier, there's different ways to implement this picture. Some organizations, compress some phases, or they might skip a phase or something like that. Okay, but it just depends. We'll talk about that in another video. So. Anyways, the next series of slides do go into great detail of each one of these phases. I'm not going to read every one of these slides to you. I'm going to highlight a couple of them, though. But I do want to say, keep in mind, this is the generic software development lifecycle, SDLC. And so some organizations, it might not look exactly like this in some organizations. However, you will find, more than likely, I don't know if I could come up with an alternate, a negation to this statement, but maybe not every organization goes through each one of these phases. However, the organizations will always generate this kind of information. Organization might say, well, we don't go through a design phase. Well, does that mean they don't come up with a design, a solution, a potential solution? Yeah, they do. They just don't call it a design phase. Okay, so what's important is the underlying structure of what we're trying to achieve in these phases. Okay, so anyways, that's what I wanted to talk to next. Okay, so it's during the planning phase where the three main things that we're doing is defining the system to be developed, we're establishing the scope, and we're making sure we have resources. Now, what you don't want to do, let's talk about the lessons learned. So heed my warning here. Number one, I don't care what kind of plan you come up with. Do not think that you're going to come up with the best plan in the universe or a risk-free plan. Every plan changes. No matter what you do, the minute you start executing a plan, something happens or goes wrong or goes different, something you didn't expect. So you're going to have to replan. You'll be changing this plan constantly. So don't spend too much time planning. Now, that didn't mean don't plan at all. But don't try to polish the cannonball, so to speak. What do you do with a cannonball? You shoot it and it blows up. So why in the world do you want to polish it too much? It's just going to blow up. So when you develop the plan, you want to make sure, is it good enough to take the next steps, okay, in the project. The other lesson learned is you want to focus on the few things that have the most impact on the project. Don't get caught up in what we consider the noise of the project. And here's a little example for you. During the planning phase, let's say right here, the planning phase is where we're at. Let's say our project, we're spending a lot of time talking about the Java code or C code that we might use to implement the project. Why are we even talking about that? Okay, that's noise. Will it need to be discussed? Yes, we'll need to talk about that eventually. But right now, our job is to make sure we've understood what it is that we're trying to build and that we've identified resources so that we can take this next step of the analysis phase. That's what we need to focus on. That's the critical few things we've got to focus on. If you spend time focusing on, well, I think we should write this in Java, and then your colleague thinks it's going to be in C, and so we're going to stand up an activity to go research what's better, C or Java, you're just wasting time. Your project's already off on the wrong foot. Okay? So, focus on the critically few things that have the most effect. Okay? I think we talked about that enough. You could pause this if you wanted to and study this. I'll bring up one thing. If we establish what the scope of the project is, like earlier I had mentioned, maybe it was the last video, about we're building an app that will identify parking spaces for students. Um, and during the project scope, we established that, okay, what this project is going to do is help students identify where there's parking. And okay, that's it. That's all we're going to build. That's what our app has to focus on. And then let's just say a month from now we're implementing the app, and you start bringing up, well, it'd be nice if the app also showed students where there's restaurants. Okay, and we start talking about, well, it wouldn't be too hard to add. We could just pull from Google Maps where there's local restaurants. We could add that to it, not a problem. That right there is what we call scope or feature creep. That's where things start creeping into the project and you're doing them, and what they're doing is they're hurting your bottom line. They're going to hurt your schedule, they're going to hurt your budget, they're going to hurt your technical quality, they're going to hurt your risk. And so what you have to guard against is this scope and feature creep. You don't let that kind of stuff creep into your project. You have to manage it. Okay? All right, some things to focus on, what we consider the axioms of leadership, or these are just the truths. That's what an axiom is just a self-evident truth. And axioms that just learned over the years. Number one, maintain focus on the problem. Stay focused. Again, back on that, the critically few things that actually have an effect. Stay focused on that. You got to control the team environment. You got to control the team hierarchy, the chain of command, if you will, what folks are working on what. Being open and honest, make sure everybody is communicating. You've got to make sure you have a strong team environment. Understanding when critical things need to be done. Keep that written on the wall in front of you. Don't get caught up in the noise. Know your teammates just like you know yourself. What motivates them? What's going to get them to work on Friday afternoon versus they're wanting to go home? Okay? And then communicate. That's one of the biggest challenges we have on projects is communication. Here's an example. What might come out of the planning phase is a Gantt chart. It's part of the project plan. This identifies the tasks that need to be done, and it lays it across the schedule, the calendar. Okay, so that's just an example. All right, during the analysis phase, so we've transitioned from planning, we're entering into the analysis phase. We interact with our end users, the customers, the stakeholders, as well as our team, our disciplined experts. And this is where we're identifying what the end product needs to be. What does it look like? We can document it in various ways. We can write things in written sentences. Like here's an example for banking. So the system shall authenticate users accessing the system. The system shall calculate the balance, blah, 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 all that good stuff. Or a way to represent the requirements is using a unified modeling language, UML, unified modeling language. Here's an activity diagram that shows the same thing about checking the balance of your account. It's a model. It shows the control flow, that there's decisions being made, there's actions being taken. So there's different ways that you can represent the requirements during the analysis phase. Okay. Two primary activities that are being done during the analysis phase. We're gathering the requirements and we're prioritizing the requirements. So prioritizing the requirements helps us, especially when you have projects that have a lot of requirements and you start identifying, well, we can't get them all built at once, so let's come up with different versions of the software and we'll allocate this set of requirements to this version of the software, that set of requirements to another version of the software, and all that good stuff. So we start identifying what the requirements are as well as what's the priority of them. And then what's really important is that we have the external folks, the customers and stakeholders, they're part of this process. So they basically have bought into when certain versions are going to have which features. So that's very important, that communication aspect. Now earlier I'd said if we screw up or make insert a problem during one of these phases, it's really going to bite you in the hind end. Well, it's during this analysis phase you can see how it grows, that if you insert a problem during one of these phases and you don't fix it until these later phases, look at how much more it costs to fix a problem later in the development life cycle versus catching the problem early and fixing it then. That's why we insert our quality assurance and our technical reviews during these phases, to try to catch all of these errors so that they don't escape the phase and make it into the later phases of development. Okay. During the design phase, it's where we're coming up with actually what can satisfy those requirements. So here's an example design and architecture, the databases that we're going to need, the platforms that it's going to run on, and all that good stuff. But here's a term that you should be familiar with as well. We could start developing what do the graphical user interfaces look like, the GUIs. So that's called a GUI, a graphical user interface. And so it's during this phase is where we're starting to identify what is that GUI going to look like. Then we move into migrate into the implementation phase. We start building the hardware, programming software, and all that good stuff. So implementation, then we fall into testing. Testing, this is where we verify that the system works as expected. So when we say as expected, well, expected to what? You got to have a reference. That reference is the requirements from the analysis phase, as well as those quality measures, or what typically will get called from the systems engineering community, the system performance measures. These are the two things that are used to basically judge whether or not the software meets expectations. Okay. During this time, we start building our test cases. Our test cases actually tell you a step-by-step how you need to exercise the software, what does success look like, what does a failure look like. But during testing is where we're trying to identify, we're trying to break it. We're trying to break the software so that we can find all the problems now versus when the software is during operations. Some projects will take various levels of testing: unit testing, system testing, integration testing, and user acceptance testing. For example, user acceptance testing is what it sounds like. You bring in the user community and you let them test it. And they were part of writing the requirements during the analysis phase, so why don't you just let them test it? And if they buy off on it, if it works exactly the way they had expected it to, then that's a great indicator that your software has met its initial needs. And then we have other different levels of testing. When we start so we typically build the system in pieces. When we start assembling the pieces like a jigsaw puzzle, we'll typically go through what we call integration testing to make sure things work together. Okay. And then I just kind of wanted to go tangential on you here in a second. One of those parallel activities that we said early on that goes on during the development life cycle, during these phases, but it goes on during every phase. One of the parallel activities was measurement. Okay, well, during the testing phase, here's some example measures that might be put in place to determine the quality of the end product. The requirements coverage. How well does the code cover the requirements, or how well does the testing cover the requirements? How often is testing discovering failures? How much time actually occurs between failing of the system? So these are just some examples of measures that we can put in place to determine the quality of the software. All right, then the last phase, if you will, we call it the O&M phase. It's where we're deploying the system to the end user, and then we're also supporting it while it's in operations. And so we'll be the four primary activities. We are doing training so that the folks can get up to speed. We're building help desks, and we're making changes, or we're building a system so that we can make changes to the software if we find problems with it after it's been deployed. Okay. I'm not going to touch on these different ways that you can deploy a system. I'll let you read that to your Okay, so that ends this part 2. And here's the challenge I wanted you to think about. So we talked about the software development lifecycle in general. There were on slide 7. Sorry, there were different types of software that were identified on slide 7. And so, do you think this software development lifecycle that we just talked about? Do you think this approach um, is applied equally the same on those different types of software? So it's something to think about. You could write down your answers. This isn't something you're turning in, but it's just food for your thought. Okay, just something for you to consider. Okay. All right. Well, consider these as additional questions for you, something to help instill the topics that we've talked about. They haven't made your homework. They might make a future homework, though. Okay. All right. Well, that ends part 2 of Learning Module 1. I'll pause there because that was 40 minutes, it looks like. So it's a lot longer than I had expected. And then I'll make part 3 to close up Learning Module 1.